Hello students of class 11. Welcome to today's your first class for chemistry. And in your chemistry, you have already seen the syllabus. So the first chapter of your chemistry book of 11 is a basic version of whatever you have studied. So I felt that I should be starting with the second chapter, that is atomic structure. Okay? So this atomic structure chapter, also you have studied about the structure of atom before as well. So there were many theories, like Dalton's atomic theory. You have already gone through this Dalton's atomic theory, even Rutherford's atomic model. Okay, so all those things you have already studied. Now, in your syllabus in 11, you have Bohr's atomic theory. So this is chapter 2. Atomic structure. And we will be discussing about Bohr's atomic theory. So as you know, in science, in the field of science, as the instrument, we get new instruments, and with the modification, what happens is the older theories are modified. So you can't say that absolutely the Dalton's atomic theory was wrong. You can't say that. You can't say even Rutherford theory was wrong. There were certain limitations, but it was modified by other scientists who came after their generation or after a few decades, and they modified based on the instruments and the advances in science. So today we are discussing about Bohr's atomic theory. So before coming to the postulates of Bohr's atomic theory, we should know what were the drawbacks or the limitations of Rutherford's atomic model. The first limitation was what? Rutherford, he could not explain the stability of what? The atom. Okay? And the second limitation was he could not explain the spectral lines of hydrogen. Now, to explain this, Bohr came with certain new ideas and he postulated them, and it is known as what? Bohr's atomic theory. The first thing is similar, that an atom comprises of nucleus, it's same. The second point is very important, okay? Now, Rutherford, he told these electrons, you know electrons, the structure of electrons, you have nucleus at the center, and suppose you have now electrons are present. Rutherford, he told that these electrons, they revolve in circular orbit. Okay? What Bohr added is, listen carefully, he added these circular orbits are fixed. What? Fixed. This was the modification. So he told that electrons revolve only in or on fixed circular orbits. Electrons revolve only on fixed circular orbits. Okay? With fixed energy and fixed velocity. With fixed energy and fixed velocity. So, what does this mean then? It means that Rutherford, he was correct to some extent that electrons revolve in circular orbit, but he did not tell that they revolve in certain fixed orbit. Okay? According to Rutherford, electron would revolve at any distance from the nucleus. It could be present here. There was no fixed. The cells would be, there would be any number of cells, and they would revolve around the nucleus in whatever distance it felt like revolving. Okay, that was Rutherford's idea. But Bohr, he told that electrons are present and they keep on revolving around the nucleus in circular orbit. That is all in agreement with Rutherford's model. But here he added fixed orbit, and this fixed orbit, it allows what? It allows there has to be certain fixed circle, means at a certain distance from the nucleus, where electrons are allowed to revolve around the nucleus of the atom. They can't revolve around at any distance from the center of this atom, that is from the nucleus. Okay, they are not allowed. They have to revolve at certain fixed circular orbits, and that's a very important point. Number 2 point, what he added that, and this is very important, quantization condition. It gave us what? Quantization condition. So quantization condition, what does it mean? It means that electrons revolve only on those circular orbits. See? Electrons revolve only on those circular orbits. Okay, only on those circular orbits for which the angular momentum which is denoted by L is an integral multiple of h by 2 pi, and this is a very important condition. What did he tell? He told that this angular momentum will be equal to n h by 2 pi. Now this n could be this n is what? Integer. Example, n could be 1, 2, 3, 4. Okay? So what does this mean? It means that only those orbits are allowed, okay, whose angular momentum would be equal to h by 2 pi. This n, if it is the first orbit or the first cell, then this value will be 1. Okay? Then if it is 2, then this h by 2 pi has to be multiplied with 2. This condition limits what? Limits the space around the nucleus, that is the orbit or the cell, okay, where electrons are allowed to revolve. So electrons revolve only on those circular orbits for which the angular momentum L is an integral multiple of h by 2 pi. This condition has to be remembered. L equals to n by n. L equals to n h by 2 pi, where this n is an integer. Please remember this one, okay? This condition. And this angular momentum L is equals to mvr, mass, velocity, and radius of the atom. Therefore, we can replace L by mvr, and we get what? We get equals to n h by 2 pi. Now, in our more simple words, what does it mean? It means that suppose you get a certain constant value here, and let me tell you this h is Planck's constant. Planck's constant, and it has certain fixed value. Okay, So this is a fixed number. This part is a constant term. Now this has a certain value. Okay, this has a certain value. Now what varies? N. Okay, what varies? N. If it is the first innermost orbit, then it is 1. If it is second orbit, then it is 2. If it is third orbit, then it is 3. Okay, accordingly we get some multiple like double, triple. Okay, so now let's move on to the third point. The third point told by him is same as that told by Rutherford. He told that the electrostatic force between the electron revolving in orbit and the positive charge present in the nucleus gives rise to centripetal force, which balances the movement of electron. Okay, and the fourth point is very important now. So this first point, second point are very important, and let us discuss about the fourth point now. The fourth point is, say, while revolving in a particular orbit, an electron can neither gain electron while revolving in a particular orbit. An electron can neither gain energy nor can it lose energy. Okay, so this is given by Bohr, and he told what? If an electron is revolving, it is present in one particular orbit, and if it is staying in that particular orbit, and if it is revolving around the nucleus, then in doing so, it neither gains the energy nor loses the energy. Now this is in contrary with what? Maxwell's theory. Therefore, this gives stability to the atom. Okay? Now, he further added what? He added energy can be gained or lost whenever there is transfer of electron. For example, say, if I give you one example here, suppose this is the nucleus, electron is revolving here, suppose, and suppose you have the other cell also. Suppose the electron is present here. Okay? At this orbit, say n equals to 1. K7. Now, whenever it gains energy, then what will happen? It becomes excited. Now, once it becomes excited, if it possesses more energy, then it can go to the higher energy level. That means in doing so, what does it doing? It is gaining electron. Okay? Now, once it reaches to its maximum excited state, then afterwards what happens? You know, excited state is unstable. Well, it wants to come back to some lower energy level. And what it will do? It will again lose the electron, and it can come back to either this, say n equals to 2 set. Then what has happened? This electron, after gaining so much of energy, it got excited. Then again it came back to this n equals to 2 set. And in doing so, it has to lose the electron. It has to lose the energy. It has to lose the energy. In such processes only, gain of energy and loss of energy is possible. Okay? They can lose energy or gain energy only when they move from one orbit, one cell to the other cell, or they come from other cell to the lower cell. If it is revolving in one single orbit, then loss of energy or gain of energy is not possible. Okay, that is according to Bohr. Now, this tells us what? It tells us that energy of an orbit cell is fixed. So, over the conclusion from this particular theory, what we conclude? We conclude that the energy of a particular orbit or cell is fixed. Energy of a particular orbit or cell is fixed. Okay? Now, he called this cell as stationary energy level. He called cells or orbits as what? Stationary energy levels. Okay? And you know, if it is the innermost cell, then its n value will be equal to 1. If it is the second one, 2. If it is 3, then if it is the third cell, say this is n equals to 1, the innermost, the second and third, likewise it keeps on increasing. Then he gave this n equals to 1 as what? K cell, this L cell, this is known as N cell, KLM cells, and these are known as what? These cells. He named them as what? Stationary energy levels. So, overall, he talked about quantization of energy, and he told what? Electrons, they don't have the freedom to revolve at whatever distance they feel like revolving around the nucleus. If, no doubt, electrons, they revolve around the nucleus in circular orbits, and they are at certain definite distance from the nucleus. Hope this is clear. Now, let's discuss about the achievements of Bohr's theory. Okay? So, from this theory, we can say that he could explain the stability of the atom. Just now we have discussed here. What did he tell? He went against Maxwell's theory and he told, say, if electron is revolving around in a particular fixed orbit, then it neither gains energy nor loses energy. Therefore, it is stable, and if it keeps on revolving in that particular same orbit. And he also told us what? See, the innermost cell, whenever you have n equals to 1, then it is known as K cell. Now, if an electron is revolving in K cell, then there is no other cell lower than this 2. There is no other lower cell than this one. Therefore, it cannot fall back to the nucleus. It keeps on revolving in that particular orbit K cell itself, n equals to 1. And we also talked about this whenever it gains electron energy, when this electron gains energy, just now I had explained, when it gets excited, and during those conditions only, they can either gain the energy or lose energy, but not whenever they are moving in one particular orbit. So, according to this, he could explain the stability of the atom. Now, he was again able to interpret the spectral line of hydrogen atom. Okay? Now, for that, we need to go in little more detailed discussion. So, from Bohr's theory, we come to know that what? We come to know the cells are circular in nature and they have fixed circular orbit with fixed energy and fixed velocity. So now, to explain this, how did he explain this line spectrum of hydrogen? Okay? So, achievement, what was achievement? He was able to explain stability of atoms, and he gave the interpretation of spectral lines of hydrogen. He was able to explain he was able to explain spectral lines of hydrogen. Now, as you know, from Bohr's theory, we come to know there are certain definite energy levels. So let us discuss that. Suppose you have, say this is the N, this is the first cell, this is where you have N equals to 1. Similarly, you have second cell where it is N equals to 2, N equals to 3, N equals to 4, N equals to 5, N equals to 6, N equals to 7. So can you see this one? Now as we are going further, as the value of this N is increasing, the cells are becoming closer and closer to each other. Now this is actually what happens. Okay, so now whenever say hydrogen atom is present, now whenever you take say little bit of sample of hydrogen atom, that means it contains so many atoms or not. 1 mole of hydrogen will be containing 6.023 into 10 to the power 23 molecules. So that you know from Bohr concept of class 10. So if you take little bit also, it contains so many numbers of atoms. Now first, let's discuss about this one. Now whenever an electron gains energy, okay, then what happens? Suppose that electron is present, say, and in this cell, n equals to 1 cell, suppose. Then whenever it gains energy, it can go to higher energy state. It can go to what? Higher energy state. It could go to this energy state. It could go to any other higher energy state. Okay? Now after some time, what happens? Once it is excited, it can stay there for a certain time, but it doesn't want to stay there for so long because everything in nature wants to come to a stable state. Now, if it happens that after being excited, after this electron goes to higher energy state, okay, and if that particular electron comes back to this first orbit itself, it could be from any of other higher cells. If it is coming to n equals to 1 cell from any other this cells, then this will give some spectral line, and that is known as what? That is known as Balmer series. It is known as what? It is known as Lyman series. Not Balmer, it is Lyman series. Now similarly, so here what you have to remember, please let me tell you once again, slowly, and here you need to understand this one, because your concept has to be clear from the beginning itself. An electron, it gained energy, it went to higher energy state. Now, it has a possibility. If it is still somewhere here, it could come to this cell, it could come to this cell, it could come to any other cell, but not lower than this one. The extreme point is what? N equals to 1. Then, if that particular electron comes back to this first cell itself, N equals to 1, from any other cells, then that will give rise to what? Lyman series. If this is clear, the other series you will easily understand it. Now, those excited, that particular electron, if that particular electron comes back to this, say suppose in the cell where n's value is 2, from any other higher cells, okay, then that will give rise to what? It could be any cell, it could be any other higher cell, then this will give rise to Lyman, then Balmer series. Similarly, if it is coming to n equals to 3 from any other higher, n equals to 3 from any other higher these orbits, then that would give rise to Lyman-Balmer LBP Paschen series. It is what? It is known as Paschen series. PASCHN Paschen series. If it is coming back to n equals to 3 orbit. Similarly, if it is coming to next higher energy level is what? 4. Then n equals to 4. Then that will give rise to another spectral line, higher energy. Okay, if it is coming from higher energy level to this particular n equals to 4 cell, that is known as what? Lyman-Balmer Paschen. It is bracketed. Okay, it is known as what? Bracketed series. 4 series and one more series is you will be having one more series, and here in bracket series the electron was coming to fourth cell from higher energy cells. Now in the next series it will come into the next higher, that is 5, n equals to 5. That means electron will be coming to this 5th cell from higher energy cells, and that will give rise to P-Fun series. Now this is giving rise to PFUNT, P-Fun series. Okay? Now, from this concept of this electron going to higher energy stationary states, and again when excited and whenever it came back to other lower stationary state, it gave rise to what? Many spectral lines. And through this Bohr explained what? Bohr explained spectral line of hydrogen atom. Now here this line of series, it lies in UV region, ultraviolet region, and this Balmer series, it lies in visible region. It lies in what? Visible region. And these 3 series, that is Paschen, bracket, and P1, they all lie in what? Let me write it here. They all lie in infrared region. So this is how he explained the spectral line of hydrogen atom. Now here, one more thing you have to remember from this particular section. You get a numerical also, and there this formula can be used to calculate the wave number, and the wave number is this mu bar is wave number, and it is the reciprocal of wavelength, and it is given by r 1 by n initial square minus 1 by n final square. Okay, and this is known as what? Wave number. This is wave number. This is, lambda is wavelength. This r is Rutherford's constant, and it has a constant value. This n initial square, nf square. This ni means originally where was this electron present. Suppose the electron was present in, say, n equals to 2 initially before getting excited, then the ni value would be 2 because it was present initially where? In second cell. Now suppose it got excited to say this, say n equals to 5. I am telling you is what? Before excitement, electron was remaining where? It was remaining in n equals to 2 cell, and after gaining electron, it will gaining energy. Since it has moved to 5th energy level, that is n equals to 5, then your n final would be 5. Your n initial would be 2 because it was where in second cell before gaining energy. Therefore, your Ni would be 2, and after gaining energy, it has been what? Excited to the fifth cell. Therefore, your Nf would be 5. Okay? Hope this part is clear. Now, this R is a constant term, and it has a value of 109,678 per centimeter. And this R is known as Rutherford's constant, and this equation as a whole is known as Rutherford's equation. Okay? This equation as a whole is known as Rutherford equation. So from here you will be able to calculate wave number, this even wavelength, and if you convert it into frequency, you can get a frequency also, because you know the relation of frequency, velocity of light, and wavelength. So this equation is very useful, and often numerical is asked from this particular section. So with this numerical, with this expression, please practice certain numericals after you get your books. So with this, we come to the end of today's class. Let me tell you at the very beginning, please don't pile up your things, because since you have chosen whether you are in pure science or in bioscience, chemistry and physics, both you have to study, and the syllabus is little you will find a little in expanded form as compared to your ICSE, and here a proper understanding from the beginning is required for understanding of the further upcoming topics. So if you don't understand this, whatever is taught today, then you will find it really very difficult to understand the topics that will be taught in coming days. So please, it's a humble request. Please practice them properly. Even after that, if you have any doubt, you will be given my number, my WhatsApp number. You are always welcome there to ask the questions related to whatever is taught. Okay? So thank you so much, and hope you will be very regular from the day go itself. Thank you.